Salam and welcome, everyone. So, today we're going to be working on the question on the screen that says a sample of 4.5 grams of methane occupies 12.7 decimeter cubed at 310 degrees Kelvin. Calculate the work done when the gas expands isothermally against a constant external pressure of 200 torr until its volume has increased by 3.3 dm cubed. So, from this question, we know that we're supposed to solve for work done when isothermal expansion occurs. So here the change in temperature is zero, meaning the temperature for this entire process will be 310 kelvins, and this occurs against a constant external pressure of 200 torr. So one thing you have to know is when you look at the first part of the question, when they tell you that there's an isothermal expansion, you could have a situation where it is an isothermal expansion that is reversible or that is against constant external pressure. And whichever one that you're given is going to actually determine the formula that you would use. Because this question is against a constant external pressure, we're going to use W equals negative P external times change in volume. So what we're really going to be focusing on in the parameters that we're given here would just be the fact that pressure is 200 torr and change in volume is 3.3 dm cubed. So we're going to just input all of that information inside this. But the issue with this is that because the unit for work is in joules, which is we can also say that to be Newton meter, none of the information here is giving us um none of the information that we have here is showing us is showing us that we could get joules from this. Generally, the SI unit for pressure is like the unit that would work for a question like this for pressure is in pascals, and the unit that would work for change in volume in a question that involves joules is meter cubed. So volume will like it in meter cubed. So we have to go from dm cubed to meter cubed. And then torr, we have to go from torr to pascals because pascals is also Newton per meter squared. So you can see now Newton per meter squared and meter cubed, they at least have something in common where meter is a unit in both of them so that we can do our calculation properly. So what I'm trying to tell you is that we don't have our question, our pressure, and our change in volume in units that would work for this type of question. So what we have to do now, before we can even input or use the formula, is for us to solve for all of this information in the proper units. Then we can successfully substitute. So the first thing you do is you should not forget that pressure, okay, here is in torr. So if we're trying to go from torr to pascals, we have to remember that 1 atm, this is what I actually used to remember all the time, 101,325 pascals. So one atmospheric pressure is the same thing as 101,325 pascal. And then one atmosphere is actually 760 torr. Hence, looking at this information, we know that 760 torr, so this is a standard conversion, is going to give you 101,325 pascal or Newton per meter squared, which is what we're trying to go. So this is a standard one. But in our question, we're given 200 torr. So we're supposed to now find what would 200 torr give you based on this fact that I am boxing right here. What is 200 torr going to give you? So of course we do dimensional analysis to solve this. So if we're given 200 torr, okay, and we know that the standard is we're going to put the torr at the bottom because we're doing unit conversion or dimension analysis. We're doing unit conversion using dimension analysis. So we're not going to put 760 at the denominator and then 101,325 Newton per meter squared, or you can just call it pascals. So torr cancel torr, 200 divided by 760 times 101,325 Newton per meter squared. All of that information is supposed to give you 26,664.474 Newton per meter squared. So this is basically what you're gonna have. Now we've been able to successfully determine what the pressure is. Now we're supposed to determine what the volume will be from dm cubed to meter cubed. So note this, and I'm going to teach you this. And if you've been watching my videos, you know that I always do this. We're going from dm cubed to meter cubed. And some of you may be confused that how do you do this? Well, one way you can do this when you're doing unit conversions like this is for you to just remember that 10 decimeter actually just gives you 1 meter, and 10, that's just the fundamental, right? Just like 1 kilograms is the same thing as 1000 grams. So we know that 1 meter is equivalent to 10 decimeter. So in order for you to go from just decimeter to decimeter cube, and for you to go from meter to meter cubed, you just have to cube the standard information that we know. So we're going to cube this. So we know 10 times 10 times 10 will give us 1000. Dm cubed, sorry, dm times dm will give you dm cubed, and 1 times 1 will give you 1 meter times meter times meter will give you meter cubed. So we go, so this is the standard information, but then we're told that the change in volume we're dealing with is 3.3 dm cube up top, the one I'm putting in the purple box. So what we just do is 3.3 using dimension analysis again, dm cubed times 1000 dm cubed, and then 1 meter cubed up top. So you cancel out dm cubed. Sorry, you cancel out dm cubed and cancel out dm cubed. 3.3 divided by 1000 would just be 3.3 times 10 raised to the power of negative 3 meter cubed. And this is basically what you have to be the answer. So, yeah, that is it. That is basically the answer so far. But that's not the answer to our actual question, because we're actually supposed to be solving for work done. So now we have all the units in the proper parameters. So we just say work done. So we're just going to rewrite the information. So work done equals negative P external times change in V. So work done is going to be negative P external is the same thing as saying um yeah, it's same thing as 26,664.474. So that would be negative 26 point, sorry, negative 26 comma 664.474 Newton per meter squared. Again, the pressure is basically force divided by area. So the unit for force is Newton, the unit for area is meter squared. So we're using the SI unit here in order for us to be able to properly solve for joules. Okay, times change in volume. We just did that. That would be 3.3 times 10 raised to the power of negative 3 meter cubed. So of course we cancel out meter squared, cancel out this. So you've just got Newton here, you've got meter. And what is joules again? Joules is the same thing as Newton meter. So I just wanted to put that there. So when you put this information in the calculator, 26,664.474 times 3.3 times 10 to the power negative 3, what you're supposed to get is negative 87.9928 Newton meter. Or we have to remember that since this is a chemistry problem or a science problem, we always have to remember to use sig figs. So in this case, everything that I'm seeing right now, at least that we're using in this question, we've got 200 Torr. We have that in 3 sig figs. We've got 3.3 DMQ. We have that in 2 sig figs. So 2 sig figs is less than 3 sig figs. So we're supposed to use the lesser significant figures in chemistry or in science. So we're supposed to round up until 2 sig figs. So that would be negative 88 Newton meter, or you can just say W equals negative 88 joules. And this is basically the answer to the question. You can see half of the work is mainly unit conversions. So you really need to know unit conversions in physical chemistry or thermodynamics. And when you know the unit conversions for a question like this, half of the work is done. You just have to use basic math. So if you guys are if you're looking to get an A and to succeed in all your STEM related courses, whether you're in middle school, high school, and in college, make sure you email me at shohabitutoring@gmail.com. I am the tutor for you. I'm a tutor for students who want to succeed. And if you have any questions, make sure you put it in the comment section. If you have any suggestions, put it in the comment sections as well. If you'd like to just book a session to see whether it works for you or not, don't forget to email me at shohabitutoring@gmail.com with your questions, your concerns, your syllabus, and just, feel free. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.